Good day, everyone. My name is Lawrence Sharokin, and I'm here to present you my topic, which is about fluids. So, what is a fluid? A fluid is any material that flows in response to an applied force. Fluid is a substance that does not possess a definite shape and easily yield to external pressure. So, a fluid is a substance that reacts to an external force and does not have a constant or definite shape, meaning it can change its shape. So, there are four classifications of fluids. One is steady or unsteady, two is compressible or incompressible, three, viscous or non-viscous fluid, four, rotational or irrotational fluid. So first is steady or unsteady fluid. Steady fluid, it is the fluid whose density remains constant at each and every point while flowing. So an example of this is a water flowing through a pipe at a constant discharge rate. Next is unsteady fluid. It is the fluid whose velocity differs between any 2 points while flowing. An example of this is water running out of a faucet when the handle is being turned. So the difference between the steady and unsteady fluid is that steady fluid has a constant speed while the unsteady fluid does not have a constant speed while flowing. Next is compressible fluid and incompressible fluids. The main difference between compressible and incompressible fluids lies in how their density changes under pressure. Compressible fluids, like gases, experience significant change in density as pressure changes, while incompressible fluids, like liquids, have a very small change in density under pressure, making them virtually constant in density. So the difference between compressible fluid and incompressible fluid is that compressible fluid's density changes when the pressure changes, unlike incompressible fluid's density. When the pressure changes, its density changes little to none. Next is viscous or non-viscous. Fluids with more thickness or viscosity are known as viscous fluids. They are generally very gloppy fluids. Examples are shampoo and motor oil. Then, fluids with comparatively less thickness or viscosity are known as non-viscous fluids. These are the fluids with no resistance or negligible resistance to internal friction. Non-viscous fluids flows without any loss of kinetic energy. Examples are or is in mineral water. So, the difference between viscous fluid and non-viscous fluid is that viscous fluid has less flow than non-viscous fluids. Next is rotational and irrotational fluids. In fluid dynamics, rotational flow refers to fluid motion where particles rotate while moving along streamlines, resulting in a non-zero vorticity. Irrotational flow, on the other hand, describes fluid motion where particles do not rotate and exhibit a zero vorticity field. So, in short, rotational flow has swirling or circular motion, while irrotational flow is characterized by a smooth, uniform velocity field. So, based on the study of fluids, they are classified into two types, which are fluid static and fluid dynamics. Fluid static, it is the mechanism of fluids at rest or non-motion, and the pressure in fluids exerted by fluids on any body. Meaning, fluid static is non-moving, meaning stationary or it does not move. Fluid dynamics, it involves the study of the flow of fluids in motion. Popular branches like aerodynamics and hydrodynamics are part of fluid dynamics. So in short, fluid dynamics are the study of fluids in motion, meaning they are moving. So these are the properties of liquid. First is density. Density measures how much mass is packed into a given volume of fluid. Why does it matter? It helps determine whether an object will float or sink in a fluid. For example, oil floats on water because it has a lower density. So, the density of a liquid, like that of any substance, is calculated by dividing its mass by its volume. So, the formula for getting the density is equals to the mass of a fluid divided by volume of the fluid. Next is viscosity. What is viscosity? Viscosity is the internal resistance of a fluid to flow. Why does it matter? It explains why thick liquids like honey flow slowly, while thin liquids like water flow easily. Next is temperature. Temperature indicates how hot or cold a fluid is. It affects other properties like viscosity and density. For instance, heating oil makes it less viscous, so it flows more easily. Pressure. What is pressure? Pressure is the force exerted by a fluid per unit area. Why it matters? It influences fluid movement and is crucial in systems like pipes and pumps. Pressure is defined as force per unit area. It is expressed as P is equals to force over area. Next is specific volume. Specific volume is the volume occupied by a unit mass of a fluid. Why it matters? It is the inverse of density and is useful in thermodynamics and fluid dynamics calculation. Specific weight. Specific weight is the weight per unit volume of fluid. Why it matters? It helps in understanding buoyancy and the behavior of fluids under gravity. Next is specific gravity. Specific gravity is the ratio of the density of a fluid to the density of a reference substance, particularly or usually water. Why it matters? It indicates whether a fluid will float or sink in water. Next is surface tension. Surface tension is the force that causes the surface of a liquid to contract and minimize its area. Why it matters? Because it allows insects to walk on water and cause water droplets to form spherical shape. Did you ever notice why some insects can walk or can stand in water? Because of surface tension. The molecule of the water contract into a small point where insect can stand on them. So that is surface tension. Vapor pressure. Vapor pressure is the pressure exerted by vapor in equilibrium which is liquid at a given temperature. Why it matters? It determines the rate of evaporation and is important in processes like boiling and condensation. Next is cavitation. Cavitation occurs when local pressure in a fluid drops below its vapor pressure, leading to the formation of vapor bubbles. Why it matters? These bubbles can collapse violently, causing damage to equipment like pumps and propellers. So here's the sample problem. The mass of water in a pot is 3.5 kg. The volume of the pot is 3.5 times 10 raised to the power of negative 3 cubic meters. What is the density of water? So, the given are the mass, which is 3.5 kilograms, and the volume, which is 3.5 times 10 raised to the power of negative 3 cubic meter. In order to get the density, we must first know the formula which density is equivalent to mass over volume. So, substitute the following, which the mass is equal to 3.5 kilograms. Then, the volume, which is 3.5 times 10 over up to 3 cubic meter. Now, divided 3.5 to 3.5 x 10 for negative 3. Then you will get 1,000. Then the unit is kilogram per cubic meter. So this is how you get the density of the water.